Up until this point, we've started to see the power of React and how useful it is to have our HTML, the structure of HTML, with the functionality of JavaScript, the dynamic nature of JavaScript, in the same place. But we have a problem, especially when we take a look at a modified version of the final code from the previous section. Right now, we just have our app component, and we're returning a div with our input. And whenever a user types in the input, there's a change event that's fired. We pass the event data to handle input change. And for right now, we're just logging the text that a user types in. Nothing significant. What's the problem here? Well, what if we wanted to do something like display the text that a user typed in the page, or display the text after a user submitted a form? In other words, if we want to store this input value, the value that a user typed in, where could we do that? If we thought about this for a second, we might opt to create a variable with let, where we could hold on to the value that was typed in. And maybe we called this value instead of input value. And we could remove this input value variable. And every time this function runs, whenever there was a new event, a new change event, we could just update this value here. So if we were to try that, we console log the result, we see that it kind of works, but if we try to display the result of value back in the page, we try to interpolate that value, nothing happens. Why does nothing happen? Why aren't we seeing the updated value even if we're seeing the value here in the console? Well, the reason is that we're not telling React that we want our app to re-render. We're using the render method to render or display our app the first time, but we want to be able to tell React, hey, this value is updated. I want you to update the UI, update this component to display the updated value. So what do we call these values that we want to keep track of within our application, such as this input value? We refer to these values as state. The values that we want to keep track of in our application are known as state. And the power of React is that it gives us a number of features that allow us to hold on to our state over time, to store our state within our component rather than using a local variable like this. And whenever this value is updated, to be able to render, to re-render the component in response. So this is a very important concept in React that we need to get familiar with. We need to become familiar with. We need to start thinking in terms of state. What values do we want to hold on to, such as values from our user, like a value that a user types in to an input. But the power of React is that React itself is what's responsible for efficiently re-rendering and re-displaying the return JSX elements in response to state changes. So it takes care of performantly updating the DOM, ultimately updating all of our HTML elements. So we don't have to be doing tricky DOM manipulation, or for example, we have to be using properties like inner HTML, where we need to reference a given div, say a div with the ID of app, where we'd reach into the DOM and get that element by ID, and then we'd store a reference to it, and we'd update its HTML with something else. No, we don't need to do that. We just need to be focused on what data we want to keep track of, and React will do the rest. So how do we use state within our React components? We'll use a new function specifically from React called useState. You can say react.useState to make use of it right away. So now we want to keep track of this value. It's typed into the input. And the first thing that we want to pass to this function is the default value. What is this input going to have as its value initially? Well, it'll likely just be an empty string. This is usually an indicator of what type our component is going to have in state. So we want to create a state variable, just like we did when we made that value declaration. And we can maybe call it input state. And what's interesting about useState is that it actually returns a couple of things to us within an array. So to actually get the state value from input state, we would need to use the first array element, and we can get that from the 0th index. So now if we provide just some default value, if we just say some text, that should be provided as our initial state, and we should see it in our output. And we just want to remove a reference to this variable that I deleted. So indeed we see some text. But now the question is, how do we update this state whenever there's a change event? Well, we'd use event.target.value to get the value that's typed into the input. And the second array element that comes from input state is actually a function which we can use to update this. So we can create a variable here for this first array element, and we'll call this input value. And the function that we'll use to update the input value we'll call set input value. It's going to come from the second element or the first index. So now to use this function, we can just pass event.target.value to this set input value function, and we can display the result with input value. And we'll put this in a paragraph element to see this better. So we'll make the default text now just an empty string. We see nothing, but when we type in some text to the input, we see immediately it's updated and displayed in the page. And that's due to the setter function here causing our app component to re-render every time state's updated. And instead of having to reference the state variable like this in this clumsy way as being the 0th element and the setter function being the first element, we can use some ES6 JavaScript to help us out. We can use what's known as array destructuring to immediately get the values from this array that useState gives us, or we can call immediately the state value, input value, and the setter function set input value. So that saves us a couple of lines of code, and our app still works as it did before. So this is a very powerful feature, what we have in this useState function. We have the ability to keep track of values, whatever values that we like within our components, and we can display those changes immediately due to our component re-rendering to display those changes whenever we call our setter function with the new value. And note that useState is the first React hook that we've covered. It's a special function that we can use specifically within function components to be able to work with state. Throughout this section, we're going to be covering a lot of different hooks that give us very useful functionality within each of our function components. So if this example was a little bit confusing, let's go with a more simple example. Let's just say we have a simple button that allows us to change the language that we're learning. And underneath it, we'll put this within a div. Underneath the button, we'll have a paragraph which displays in our app, I am learning, a given language. And we want to store this language value in state. So we want to create some dedicated language state. So how do we do that? First, we execute the useState hook. We figure out whether we want to give it a default value. And let's say by default we're learning Python, but we want to change this to JavaScript for obvious reasons. And what do we get back? Well, remember we get back an array, and we need to use const or some keyword to declare a variable to declare the two things that we get back from useState. We can destructure these. The first is the state variable, which we'll call language. And the second is the setter function. And the convention is to prepend whatever we called the state variable with set. So this will be set language. So when user clicks on this button, we want to set the language to change it from Python to JavaScript. So we'll add an onClick. And your first impulse might be to create a function that we connect this to, maybe called handle button click. But in many cases, when we have just some simple logic that we want to implement, we can include a function inline here by writing it as an arrow function. So we can write an arrow function just like this. And we want to call setLanguage and pass it an argument of JavaScript. Now, the reason why we need to write an inline function here is because if we write it like this, this will be called immediately. We won't have to click on the button. When there are components rendered, setLanguage is going to be called and state's going to be updated to JavaScript, which is not what we want. We only want the state updated when the user clicks on the button. So that's why we only want to execute this function and pass in that argument when the button's clicked. So that's why we need to actually call setLanguage with the argument in the return of the function. And then we want to display the updated language in our paragraph element. So we'll do that between a set of curly braces. So let's save this. So currently we're learning Python, but if we hit change language, now we're learning JavaScript. So this gives you a couple of clear examples of what we might want to keep track of. We've covered button state and input state, and of course we can combine them within a single example. So let's say we not only want to display what language we're learning, but we also want to display how many years of experience we have. So what can we do if we want multiple state values? Can we only use one state value in our component? We can use, in fact, as many as we need. So we can call useState again, right after the first useState call. And here we want to keep track of how many years of experience we have as a developer. So what would a good default number be? It might be 0. So we want to keep track of a number here for our state. And then we want to destructure the state variable. And we'll call this years experience, as a developer. And the setter function will be set years experience. So now underneath our button, we'll add an input. And we'll spread this over multiple lines. First of all, we want this input to have a type of number. And when a user types in, a change event is going to take place. And once again, we can write this with an inline function. We don't have to create a separate handler function for it. So within the arguments, we're going to get access to the event. And then we want to call setYearsExperience. And we're going to pass through event.target.value. And then create another paragraph element underneath that says I have, and then interpolate the number of years experience. I have so many years of experience. If we save this, we might want to put this input on a separate line so we can wrap that in a div. And if we increase this, we see it keeps what's displayed in the UI is kept in sync with what we've put in the input. So we're also keeping track of our year's experience state. So we can have multiple separate use state calls within an individual component, but note that use state can accept primitive values, that is strings and numbers and booleans, as well as object values or reference values. So we could organize both of these values on a single object if we just want to call useState once. So let's see how we would rewrite this. We'll comment both of these lines out. We'll say react.useState, and we'll pass in an object for the default value. Now, we're keeping track of the language, so we'll want to make a key called language, and that had a default value of Python. And then our year's experience state, which was 0 by default. And we want to give it a different name than both of these keys that we've included on our object. So for our destructured state variable, we'll declare that as developer, since we're keeping track of our developer information, what language we're learning and the years of experience we have. And our setter will be set developer. Could maybe call it developer info if we wanted to be more precise. Now, what do we need to do to change how the developer state is updated, since we don't have the setter set language or set years experience anymore? Well, we can leave the functions here. We can leave these as inline functions. We don't have to change that, but we want to call set developer. Now, what's important here is that we want to figure out whether we can update the entire object at once or if we only want to update a single key value pair. So here when we're changing the language, maybe we'll want to update the entire object. So when we pass in a new language, we set language to JavaScript. So we're passing in a new object as the new state value to replace the default one. The language is going to be JavaScript, and we might want to set years experience to 0 no matter what. So we're replacing the entire state. But in the event that a user's typing in the number of years experience they have, we want to keep the language the same. So note that when we're using an object for a state value, we have to make sure that we're bringing in the previous state. We want to, if we're updating the years experience, we always want to hold on to the fact that we have JavaScript or Python as our language. So how do we only update one property at a time when we're using an object as a state value? Well, first of all, let's replace set years experience with set developer. And what we want to do here is we want to spread in the previous values of developer object. That would be the language in this case. And we only want to update the years experience property with event, the current event.target.value. So now let's try this out. Well, we also make sure to grab the individual properties from developer and display them in our elements. So now this should be, instead of language, developer.language and developer.yearsExperience, since they're properties of that object. So if we want to change our language, you see we change it from Python to JavaScript. That works fine. And when we want to increment our years experience, note that since we're using this spread operator, forgot to mention that this is the object spread operator. It spreads in all of the previous properties and values that we had in state. Since we're keeping all other properties and values the same, we're just updating the years experience whenever we're incrementing or decrementing the input value. And when you're in a position like this, when you're using an inline arrow function, it can be a little bit confusing to read. So if you want, you can extract this and turn it into a separate function if you like. You can make this a bit more declarative. You can declare what's taking place. So for our button, we can say handle change language. That doesn't accept any arguments. We can just copy set developer here. And now we can have it reference the function. The onClick can reference the function handle change language. And then we can create a function for our input called handle change years experience. And that will accept an event. And we can copy what we were previously returning. We'll replace that with the reference to handle change years experience. And make sure we don't write this like a method, but we always include the function keyword. That can be a common source of errors. If you're switching from class components, we see that it works just like before. And one final thing to note, if you have a piece of state that you need to make sure is updated reliably and depends on a previous state, you want to use a specific pattern. So for example, let's say we have one additional property here in our state object. We might have a property called isEmployed, which is either true or false, which keeps track of whether we as a developer are employed or not. So let's say by default that's false. This is either going to be true or false, and it's either going to be changed from false to true or the opposite. So in other words, isEmployed is always going to be dependent upon a previous value of state. How do we ensure that it's always updated correctly? Well, first of all, let's create a button, new button up at the top to update this. We'll call this toggle employment status. And we'll add an onClick. And we'll have it reference a new function, which we'll call handle toggle employment, which we'll make. And once again, we want to call set developer and we only want to change this one property, isEmployed. So again, we want to use the object spread to spread in all the previous values that we have, all the current state, and just update isEmployed. But how do we update it? Well, we could take the current value of isEmployed from developer.isEmployed, and an easy way to change a Boolean value from false to true and back is with the single exclamation point operator called the bang operator or not operator. So we could say isEmployed, the new value is going to be the opposite of its previous value. But one important thing to note about state and how it works is that state updates are asynchronous, meaning they're not immediate. They take place over an unknown amount of time. So how do we guarantee that whenever we're updating state, that it takes place, the state update takes place before we see the next change in the component UI? We don't want what we see on the page to be out of sync with our state. We want our state to be known to operate as our single source of truth. So there's an even better pattern that we can use here. Within setDeveloper, which is a function, we can actually access an inner function. And within the parameters of this inner function, we can write this as an arrow function, we can get access to the previous state, which we'll just call prev state. We could also maybe call this previous developer. And we want to make sure that we return this new object. So we want to wrap that in another set of parentheses here. So we can remove these parentheses around the parameters if we like. But to make sure that this is updated correctly, we can spread in, instead of developer, the previous state, which is the same as the previous developer object. But it's just guaranteed to be that previous value. And isEmployed we can change to previous state dot isEmployed. So now whenever we toggle the employment status, and we can display it here at the very bottom, we can say employment status, and we can use an inline ternary to say, if developer.isEmployed is true, then we show the text employed. Otherwise, if it's false, we say unemployed. So if we save now and test this out, when we want to toggle our employment status, we can feel confident that the state that we see on the page is in sync with the state that we have stored here within useState in our local component state. So the useState hook is pretty great. We can now keep track of values. Whenever we update those values, React knows how to performantly update our UI. We know how to keep everything in sync with the help of some tricks like this updater pattern. We usually call this inline function that we have access to within the setter function, the updater pattern. But what about if we want to reach out into the outside world? We're still really dealing with everything in our app as something local. We're creating the elements. Any state that we're holding on to comes from these elements, maybe comes from an event, and we're storing it here, which is great, but it's almost inconceivable to think of an application that doesn't interact with the outside world, say where we need to interact with the DOM itself, where we need to interact with the browser, where we need to interact with an API to fetch data or something like that. So how do we do all that? What do we do when we want to reach outside our app to bring in data or to bring in functionality that's located outside of our app? Well, let's say, since we're providing information about our developer here, we see up at the top that we just have in the title, the text. We look at the title element, we just see the text React app. Instead, maybe we want to show the developer's name. We're showing a lot of information. This perhaps is about ourselves. But whoever's using this app probably wants to have their name included. In order to update the title, this is something that we can't directly access within our component. We can't access it anywhere here. In the same fashion that we had to, in getting the root node, reach out and find a div with the ID of root, we need to use document. We need to use the DOM in order to grab the title and update its value. So where would we do that? Let's introduce a new hook that's created specifically for these types of actions. And just to add a bit of terminology, whenever we want to interact with the outside world, we want to perform what's known as a side effect. So here we want to work with the DOM, which is a browser API outside of React that's located on the window. So just like we have our first state from the React package, we are going to use a new hook from React that allows us to perform side effects called logically useEffect. Now we want to be able to do something here within useEffect. So what's also logical about it is that useEffect accepts a callback function. And in the callback function, we specify what we want to happen. A callback function is just something that is called back from the function it's passed to. So we can either pass in a normal function with the function keyword. You can see here we have an anonymous function declaration. But just for simplicity's sake, to write less code, we can use an arrow function. That's what I'd recommend. So here, all we have to do is within the function body of this callback, and note that this callback is known as the effect function. Here is where we can access the document API, and we can update the title property, and we can set it to whatever we want. So right now, let's just hard code a value of, let's say, John. So when we save this, we see John added to the title. So this seems simple enough. We might want to add an additional piece of state that allows us to make this value dynamic. So let's say we have a name property. By default, that'll be an empty string. And so instead of having John, we can set that to developer.name. And then we want to make an input. We can just copy the input that we already have, an input of the type text. And for the onChange, we want to be able to update the name state. So we'll call this function handle change name. We get our event and take event.target.value, and we want to once again call set developer, and we'll spread in the previous developer state and set name to what's on event.target.value. We're familiar with this. Now we just need to connect handle change name to our onChange. And when we might want to add a placeholder to this so we can see which input we're working with. So when we type in here, we see that the title updates. But one thing I want you to take note of is that yes, we've made this dynamic, but if we insert a console log here, we just say runs. Let's see when our effect function runs. Naturally, it's going to run whenever we update the name by typing into our input. But note something else. Note that it's also going to run, let's just clear this out, it's also going to run whenever any other piece of state is updated. We see our employment status is updated, so another property on our developer state's changed, and it runs again. Now that's not what we want. We don't want to be doing something that's potentially expensive, like a DOM update, whenever any piece of state or any property on a piece of state changes. So what can we do? So just to be clear about what's happening here, whenever state's updated, the app re-renders and useEffect runs. useEffect calls our effect function. How do we change this behavior to make sure the effect function only runs when our name property actually is updated and nothing else? Well, now we need to add an additional argument to useEffect called the dependencies argument. So we'll add a comma, and dependencies is provided as an array. So first this is going to be provided as an empty array. And this is where we list all of the things that our effect callback is dependent upon. This is what allows us to conditionally run our effect function. This is what we want, to conditionally run this function. So we have to figure out what this function's dependent upon, or in other words, what piece of state we want it to sync with. We want this to sync with just our name piece of state. So we need to include that. We need to tell useEffect about it. Hey, only run this function when our name piece of state changes, and at no other time do it. So now let's save and see what happens. So it runs initially. Be aware that when you include this dependencies array, it's going to run at 2 times by default when the component mounts, meaning when it renders all of the elements, and when it unmounts, when it's removed from the DOM. So it runs initially. When we type in here, we see that it runs every time we type. If we clear this out now, but when we toggle our employment status now, which is only updating the isEmployed piece of state, we see that it doesn't run. So this is a very important part about useEffect. We always need to be asking the question, what piece of state do we want our side effect to sync with? And if there is such a value or values, note that we can include multiple values here, listed as separate elements. We include it in the dependencies array. We have a pretty extensive example here, but right now I'm going to clear everything that we have and replace it with something simpler since it's starting to get a bit complex. So we'll remove everything that we have returned except for a div, and we'll remove all of our state. And instead of having an app, well, we could leave the component name the same. For our component, let's say that we want to keep track of the mouse's position on the page. I mentioned keep track. Your ears should immediately prick up at that and start thinking state. We want to store this position in state. So let's create some dedicated state with the useState hook for the mouse position. And I'm going to tell you up front that we're going to manage this with an object, and we're going to have 2 properties on it, the X position, the horizontal position of the mouse, and it's going to have a default value of 0, and the vertical position Y is also going to have the same default value. And we're going to call this state variable mouse position and the setter set mouse position. Now this is another instance where we want to perform a side effect. Why is that? Well, we want to keep track of the mouse's position in the browser. And the way that we do that is using the window API. So we're going to say react.useEffect will provide as the first argument our effect function. And by default, I'd highly recommend that you include just an empty dependencies array. You'll be using this, even an empty dependencies array, more often than you will be just using a single argument for useEffect. And what do we want to do here? Well, we want to set up an event listener to keep track of the mouse's position. So we want to say window.addEventListener, I should say document.addEventListener, and we want to listen for the mouse move event. And we want to get, for our callback, we'll provide a callback function here, which we'll call handle mouse move. We'll create that underneath, handle mouse move, and we'll get access to an event. And from the event, we'll get event.pageX, which is going to give us the horizontal position, and event.pageY. So using this, we can call set mouse position and pass in new object with X set to page, event.pageX, Y set to event.pageY. And we want to display those coordinates in the page, so we'll create a paragraph where we'll display the X value from mouse position dot X and Y from mouse position dot Y. So if we save and we try moving around the page, we can see immediately whenever we move around, our X and Y position is updated accordingly. Now within an actual application, this might be one page of our app. And when we go from one page to another, the components from the previous page are removed. They are unmounted, so to speak, from our app. So that means our state value is going to be removed. So to simulate moving from one page to another, I'm going to create a set timeout where after, let's say, a couple of seconds, we're going to re-render the app. Actually going to re-render the app with a different component. We'll just make this any component. I'll just say test. We could just say new page. So this will simulate going from the page that displays our app component to another page. So let's save and see what happens. First of all, we can track our mouse movement, but when we move to the new page, we see this error. We get a warning, can't perform a React state update on an unmounted component. This is a no op. It indicates a memory leak in your app. What does this mean? Okay, this seems like a complicated warning message. If we look here at the end, it makes a little bit more sense, however. To fix cancel all subscriptions and asynchronous tasks in a useEffect cleanup function. Okay, so really what's happening? As I mentioned, when our component unmounts, when app is removed or no longer rendered, instead of app being rendered, we're now rendering new page. When it's removed from the DOM, our state is removed. But what happens when we call useEffect is that we're setting up this active event listener. We're still listening for the mouse move. So what it tries to do is it still tries to call this handle mouse move function and set the mouse position even though we no longer have our component and therefore this state variable anymore, or the setter function. So that's what explains the error message can't perform a state update on an unmounted component. It's not there anymore. So it's still using this listener. Our app is still keeping this function around in memory. This indicates a memory leak. So what can we do? Well, as the suggestion says at the end, we want to cancel all subscriptions and asynchronous tasks. We want to remove all listeners at the very end of our useEffect callback. So how do we do that? Well, useEffect allows us to return a function at the end. Again, it can be a function declaration or an arrow function. I'll write it as an arrow function, again for simplicity. And this is where we want to cancel any active listeners or subscriptions that we might have. So here we want to call document.remove event listener to get rid of that. Again, we're going to remove the mouse move listener and the reference to that function handle mouse move. So now when we save, we can track position at first, and when we go to the other page, we no longer have that listener trying to update state on a component that's not there anymore. So we've been working with one API up until this point, the document API, the DOM. But now let's talk about an API that allows us to fetch data. An API that we have to make an HTTP request to get stuff from. So since you likely have a GitHub account, you have an account at github.com, let's see if we can fetch our own GitHub data. We can do so easily. First, let's just clear out the example that we have here. And right now we're just going to return a div with the text user. We want to make a network request. So again, we're working with an API. We want to use the useEffect hook. And again, we'll provide an empty dependencies array. We want to run our effect function only once our component mounts. Again, our empty dependencies array is going to make sure of that. This is what we're going to want to have for any situation where we're making an HTTP request for some data. So how do we make a request? Well, we can use a tool from the window API, namely the fetch API, the fetch method. This allows us to easily make requests. So we can just reference this as fetch, and we just need to provide an endpoint. So to be able to fetch data from your GitHub account, you just have to use the following URL, https api.github.com/users/ and then provide whatever your handle is, whatever your username is on GitHub. You can use mine if you don't have a GitHub account. And we'll provide this, we'll put this in a variable called endpoint. So here within useEffect, we can use fetch, and fetch returns to us a promise. So that means we can chain on a then callback, we get back a response, and we need to execute or resolve another promise, and we're going to get back JSON data, so we can say response.json, To resolve that, we'll use another then. And then finally, we'll get our user data. So for right now, let's just console log that and make sure this is working. So we'll save. And once our component mounts, we want to remove our new page component here. We see a split second after our component mounts all of the user information back from GitHub. Great. And so naturally we want to store this. We want to store this so we can use it in our returned JSX. So we'll create some dedicated user state, react.useState. And since we're getting back an object, the default value for an object is usually null. And we'll create a user variable and a setter function. So here, instead of logging data, we'll call setUser, pass in data to it. And if we look at all the stuff that we have here, we have a bunch of properties now accessible from user. So we can return maybe within an H2 our, let's see, our name from user.name. Maybe our bio and a paragraph from user.bio. And we'll add a small image. And we'll say this is our avatar. And we'll give it a source of user.avatar_URL. Okay. And we'll use style to say the height should be 50 pixels. Oh, and it looks like we're getting an error here. Cannot read property name of null. So since it takes some time for our promise to resolve, and since we have a default value of null, we're trying to get a property from null, which doesn't work. That's why we're getting our type error. So to fix this, we can add a simple conditional, and we can say only if we have a user. If we have a user, then we want to display our data. Otherwise, maybe we want to just display the text, then a paragraph element loading. So we see loading briefly and then our actual user data. Perfect. So note that this is exactly how we want promises to operate within UseEffect. We can include them directly within our callback function. But what if we want to use a different syntax? So for example, to resolve this promise, we could use the async await syntax, where instead of writing these then callbacks, we could have an async function, and we could resolve each of these promises with await instead of using then. So what we might be inclined to do is we might want to make our effect function async, and then say fetch endpoint, and this is a promise, so we'll await it. And since we're using await, we can immediately put the response in a variable of the same name. Then we want to await response.json to resolve that promise. We'll put the result in a variable called data, and then we can call setUser and pass data to it. So let's try this out. Let's hit save, and it works, but we're getting a warning here. It looks like you wrote useEffect with an async function or returned a promise. So instead, write the async function inside your effect and call it immediately. So what useEffect doesn't want us doing is making this effect function async, where any function prepended with async returns a promise. So it's saying you need to create a separate function directly within useEffect. So all right, let's try doing that. Let's create a function called getUser. And we'll make that async. Prepend that with async. And we want to immediately call getUser here. And when we do that, when we hit save, we see all of our errors go away. So that's just the quick fix for using an async function within useEffect. So be aware of both of these patterns, both the normal promise pattern, the normal older pattern for resolving promises, as well as this newer pattern when you want to use async await within useEffect. So what we have so far is a decent example. It's okay, but what if we wanted to make this a little bit more dynamic? What if instead of having just this hard-coded, unchanging user that we keep fetching, what if we wanted to provide an input, the little button, that allowed us to provide a given user's username to search for them and display their data based off of the query, whatever username that we provided. So thinking about what we want to do, we want to store a new piece of data in state. And that data is going to come from an input. So let's first create an input, let's say above all of our user data, the data that we're displaying. But we don't need to show that conditionally. So let's wrap this entire ternary in a set of curly braces. Let's interpolate that and surround it with another div. And that's going to allow us to, no matter what, insert an input above it. And in addition to this input, we'll give it the type text, and we'll give it the placeholder of input username. We'll also provide first a search button. We'll call this search, or give it the text search underneath our input, and we'll also have a button that will be used to clear our input. You can see both of those here. So whenever we click on, or a user clicks on the search button, once they've typed in a username, we want to be able to search for them. And when they hit clear, we want to clear out this input. So first of all, we want to add an onChange to our input, and we want to update our username state. So let's create a new piece of state. By default, let's say this is my username. We'll call this variable username. Setter will be set username. And whenever a user types into the input, we want to take the event, and we want to call set username, pass event.target.value to it. So whenever user types in, username is being immediately set, but we don't want to immediately get the user whenever username changes. So we don't want to include username here as a dependency, because that would mean our callback, our effect callback, is going to fire and call getUser. It's going to fetch user for every single keystroke, every single time we type into that input. We only want to fetch the user when we click on this search button. So how do we enable that? Well, first of all, we want to change the endpoint so that it doesn't have this hard-coded username of my username. So instead of calling this the endpoint, we might want to call this the base URL. And we want to pass in the username value whenever we call getUser. We can pass in getUser here when it mounts. We can call this parameter route to make it a little bit different, or we could also call it username if we wanted, but I think it gets a little bit confusing. And then we can use template literals in order to add route to the very end. Use the interpolated route, the $ and curly brace syntax, as the end of our route that we're fetching here. So if we briefly save, when we refresh, we still get the same default user. But now when we type in the input, we're updating the username. The user that we see in the UI doesn't update yet. And when we click on the button, search, we want to actually execute getUser again and pass it the new route. So to be able to do that, we are going to need to move getUser into the outer scope, because at this point, only the effect callback has access to it, can use it. So here in button, we want to have an onClick, and we want to include an inline arrow function to be able to call getUser with the current username once again. So now when we save and we provide the username, let's provide some random user, and we hit search, we see the user right here. And now we no longer need to include username here, since getUser has access to username in the global scope. We don't need to pass it there again. And we also don't have to pass it an argument when we click on our search button. We can just call getUser. So if we save and try that again, oops, I immediately called it. Should just pass it as a reference. Now, let's try that again. Hit search, and it still works. Now, the last thing that we need to do is figure out how to clear out the input. How are we going to clear out the input when we click on this clear button? And maybe we also want to focus the input, so it allows the user to easily type in something else to be able to search again. Well, to do that, we want something a little bit different. We want a way to access this input so that we clear out its current value and then we also focus it. So to be able to reference individual elements like input, we use a new feature in React, a feature that we haven't touched on before, called a ref. Ref is basically short for reference, and it enables us to reference a given element to be able to do things like we mentioned. This is particularly useful for inputs and forms and things like that. Unfortunately, there's another hook that we can use that makes working with refs a lot easier. And that is, as you might have guessed, the use ref hook. Just like the other hooks, we can call it up at the top of our component. We can pass it an initial value, but we don't really have to. And it gives us a return value. And here we're going to call this our clear input, because that's actually our search input, my mistake. We want to reference our search input here. We want to clear out its value and focus it. And the way to use a ref is that once we get this return value, search input, there is a special attribute on each element that React puts on each element called a ref. And that's what we connect the return value of use ref to. So now, once our component mounts, we can reference this input using search input. So what does this enable us to do? Well, now we can use this clear button. We can add an on-click and connect it to a new function, handle clear input. And we can add that above our use effect. Normally we want to have our use effect closely to the state that it's updating. This is called co-location, where we have our effect hook closely paired with the state that it's updating. So we want to create a new function, handle clear input. And now we can use this search input reference. And what's neat about refs is they basically function like a box that we can put anything into. And that box is located on this current property. So we can put things on it, or we can use it to manipulate our elements. So here with our search input, we can use current, specifically a value off of current called the value property. And we can set that equal just to an empty string to clear out the input. And then also to be able to focus our input, we can say search input.current.focus. So in addition to properties like value, we can use methods on it like focus to give us some additional behavior. So now once we save and type in a user, hit search, that user's loaded, we can hit clear. Once we do so, our input's cleared out and our input's also focused, ready for us to type in the next username. Perfect.